This thing is going to throw a lot of chips, so we need to create an enclosure for it. Using Fusion 360's sheet metal design, we can see how the different sections are going to lay out. We can create a flat pattern, lay it out, and cut it up. Getting set up for the initial bends, there's a lot of unusual cuts and angled bends to make on these side pieces. I did an initial test with some chips from the other mill just to see what angle it was necessary for the chips to slide down so they come off easily and slide into the bucket at the bottom. 30 degrees seemed to be the appropriate angle, at least what I found, based on dry chips. Getting this thing bent with a homemade bender was just about the worst. I really wish I had a professional bender, or at the very least a Harbor Freight or some sort of bender actually made to bend metal. As it was, I oversized this bender and I had a lot of flexing, and the bends in this thin sheet metal came out okay, but later trying to bend some aluminum made for a lot of headaches. So for finishing touches, I tried to remove as much rust as possible. I applied a primer coat of an oil-based bonding primer to help with adhesion, and a final oil-based coat to seal everything up. The paint is mostly there just to prevent rust. It does make it look a little better, but mostly there just for rust. We're getting close now. Final assembly. Adding an encoder to the Z-axis along with the cable track. Keep cables from getting bound up. See here I'm adding a 16mm ball screw, although I change this out later for a bigger one, just for more stability, more rigidity, and a little bit smoother action. Now 400 or 500 pounds. My main plan was pretty much just not to drop this on my toes. The hard part was that I did not pre-plan on how to get this thing into the right position. The engine hoist I was using barely had enough length or enough stretch to get this thing high enough, and the legs kept running into the legs of the frame, so getting into the right position was kind of difficult. Took some muscling, but I managed to get it in there just through brute force. know if I've mentioned it yet, but these limit switches, or home switches actually, are precision switches. They are from Metro, which I believe is Japanese made. They are precise to within 2 10,000ths of an inch. The nice thing about that is once I set my home location, if I have an offset, it should be relatively easy to go back to that offset and have it be very accurate. Just finishing up the x-axis here with some limit switches. These limit switches are set up to be normally closed, which is a little bit safer than normally open because the computer would only read if the signal is broken, as opposed to any EMI, electromagnetic interference, where it just clicks on momentarily. As I mentioned earlier, we have some missing holes for the linear rails, or the linear rail blocks, and as promised, we're going to machine those on the actual machine in the right position. So to finish up, I'm just machining the subplate flat before we put the table on. I was trying out this end mill, which is a round insert end mill, and I have way too much stick out here, I know that, but I really just wanted to try it out and see how it cut. And it cut okay. There was a little bit of vibration, but for the most part it got the job done. So as we're coming to the end, I just want to point out that I did not make a video on the electronics portion. I have the electronics box all wired up, and if anyone is interested, I could make that video, maybe if like more than one person is interested. So let me know. It won't be so much a step-by-step as just an overview of how things are wired. So thanks for watching.